Track Factory. Today we'll talk about the first things to inspect on your chassis to begin sorting its handling. Think of it as your motorcycle's skeleton. You need well-aligned bones with properly supported and flexible joints. Stick around and we'll talk about a few basic techniques I use to get a solid base setting. In this video, we'll look at chassis maintenance and adjustment fundamentals. While reading up on this topic before filming, I was reminded just how complicated chassis design and dynamics can be. And I'm not really qualified to speak on them. If I were, a short video wouldn't begin to cover even the basics anyway. Here's a resource written by Vittorio Cosalter, an Italian professor of applied mechanics. I'd like to start by reading a brief passage that helps illustrate the difficulties in sorting a racing motorcycle's chassis. In practice, defining the motorcycle's handling quality is not an easy task because it constitutes an overall characteristic determined by different components of the vehicle: engine, brakes, aerodynamics, frame, tires. Moreover, there's a strong subjective involvement in the use and rating of the motorcycle on behalf of the driver according to the driving style and sensitivity. In other words, there are many factors, and different riders experience different things in the same situation. This is why we talk with our hands when we're trying to describe what the motorcycle is doing on track. Today we're going to assume that our chassis was built correctly and not bent. Mostly we're going to talk about what I check and maintain throughout the season. This will help us eliminate some of the surprisingly common problems that creep into our chassis over time and throw us off the trail of a good setup. First we'll check the steering stem, then the swing arm pivot bolt, and then the axle. The first thing we're going to check with the steering stem is for any type of grittiness, notchiness, or punctuated movement. There's two big bearings in there, and I want to make sure that there's no obvious damage. This feels nice and smooth. Second check we want to do is slowly turn this, and then when it gets towards the end, it should fall naturally. That helps determine if it's tight enough or too tight. The next steering stem check is going to be lifting the motorcycle front wheel in the air with the center stand support, and then pulling firmly on the bottom of the forks forward and then back. And there shouldn't be any movement. Now the bike is moving, it's squishing on the rear sidewall, but there is clearly no movement in the steering stem. I want to check for any type of clunk type of motion. That feels good there. Moving towards the rear of the motorcycle, we'll now look at the swing arm pivot bolt. There is a torque specification on this bolt of 65 to 75 pounds from a Can-Am Sonic 500 manual. We'll go with that. We don't want it too tight because the steel spacers in the center of the swing arm will dig into the engine and damage it. We don't want it too loose, then it will vibrate under load and gall the cases. To more easily view which parts move on which, I've moved to the spare chassis without an engine. This piece here we'll call the swing arm pivot bolt spacer, is what presses on the engine cases. Inside the swing arm is a oil impregnated bronze bushing which rides on the outside of this. Dirt gets in there, so this will need to be disassembled, cleaned, relubed, and reassembled, and the swing arm reattached to the engine. When the swing arm has been installed and torqued to the appropriate specification, with the shock off of the motorcycle, then we are going to lift the swing arm and make sure that it drops freely under its own weight. At the proper torque specification, the swing arm should move freely. If it doesn't, there's something bound up and you're going to have to determine what that is. Our next check is going to be that the rear axle is parallel with the swing arm pivot bolt. We don't want the axle adjusted such that it's in a bind that one end is farther back than the other. Then your wheels are not in line. How do we do that? Well, we'll go ahead and make sure our adjusters are all the way forward and then measure from the center point of the rear axle to the center point of the swing arm pivot bolt. There's a special tool that does this very accurately. To use this device, one goes into the axle and one into the swing arm. The conical device with the thumb screw centers it in each bolt hole. Then you measure from tip to tip. Super cool tool, as I like to say. If you don't have something like that, you can very carefully use a tape measure and get fairly close. This obviously is not ideal, but it's better than nothing. Once you have your axle adjusted completely parallel to your swing arm pivot, any adjustments that you do on one side, you will do exactly to the other. Also, you can use this specialty tool that I mentioned in another video to check. After your axle is completely parallel, then verify that your threaded adjusters are sticking out the same amount. If not, you can go ahead and grind them a little bit so they will be a valid reference point going forward. Now we'll check the suspension for any type of slop in the bushings in the shock eyes, or if you have a linkage suspension in any of the linkage. This bike does not have any linkage, it's just checking shock eyes. So we'll pull up and down on the swing arm and make sure that there is no slump. We're good here. I've switched to the dirt bike to demonstrate checking the shock and forks for damping and stiction. The frame flat track bike is just so stiff, it's hard to demonstrate. But the principle remains the same. What we're checking for is actual damping with oil, not just spring or blown shocks. In other words, there is no hydraulic damping when shocks wear out or the seals blow and oil and pressure leaks out. So we're going to push down firmly and release. And we should feel spring resistance and liquid hydraulic resistance. Maybe you could even feel that or hear it. So that feels pretty good. Flat track bikes don't have a front brake, so we'll need to put the front tire against a ledge. This one here in my shop works well. And then we'll do the same by pushing down on the fork sharply and feeling for any type of sticking, and make sure that we feel some sort of hydraulic resistance, not just spring. This bike, I actually do feel a tackiness on the initial application of pressure. Stiction, they call that. So these forks need to be worked on. Those are your flat track chassis basic checks. Each one of those topics could probably be broken down into a video of its own. If you'd like to see something like that, or think I forgot something, let me know in the comments below. Thanks for watching.